chemical fuels. Here we consider the chemical fuels. All fuels are comes under what we consider it as a chemical fuels. Just take an introductory part of fuels. What do you mean by a fuel? If you burn a component which can able to produce energy, it may be in the form of heat or light. We consider as a fuel. Or in other words, it is the right correct way of defining a fuel. It is a combustible substance. You can burn that substance. Okay? It's a combustible substance. That is very important. It's a combustible substance. Chemical fuels means it is a combustible substance containing hydrogen and carbon as a main constituent. Okay, so if any components which contains hydrogen and carbon, which on proper burning, this is a combustible substance, on proper burning. To burn, you need oxygen. Yeah. So fuel is a combustible substance containing hydrogen and carbon as a main constituent. Along with this, there are some other components present, okay, which on proper burning in the presence of air or oxygen. Okay. Here, if you introduce air, usually we'll take air, it contains oxygen with the help of oxygen. And then for ignition, to burn that one, you have to supply a heat or light energy. Yeah? So that's the things here. Okay. Burning takes place, thereby producing, if it contains carbon and hydrogen, it produces carbon dioxide and water, and liberation of significant amount of heat and light energy. And that substance, what we call it as fuel. Okay, that is, it is a combustible substance. So the fuel is a combustible substance containing hydrogen and carbon as a main constituent, which on proper burning in the presence of air or oxygen produces carbon dioxide and water, with the liberation of significant amount of heat, or that is the liberation of significant, that this energy is usually utilized, okay, or further we may convert it into power. Okay. And this carbon dioxide water, it is usually an undesirable substance. Okay. And this can be conveniently used for domestic as well as other purposes. Okay. So in general, the car fuel is a combustible substance which containing carbon and hydrogen as a main constituent, which on proper burning in air or oxygen produces carbon dioxide, water, and liberation of heat and light energy. So these are the common fuels what we used: wood, charcoal, coal, kerosene, petrol, etc. Okay. So the next, while choosing fuels, we have to consider their properties. So that is what we consider as the ideal fuels. So the ideal fuel should readily available. Okay, you can access that fuels readily available. It should be cheap. Okay, and that fuel easily burn in air at moderate rate, not rapidly. If it rapidly burnt in air, then again there is a loss of energy. Okay, so that's why it should easily burn in air, but moderate rate, and should contains low moisture content. So if moisture content is more, then there is a loss of energy. And on burning, you should use a large amount of heat. Heat energy should be very high, and it should not leave an undesirable affect the environment adversely. And while in any fuels, for burning, not only oxygen, even you have to burn it in the medium, yeah, using heat energy. And their ignition temperature should be moderate. If it is very low, it rapidly catches fire. If it is very high, then to start the burning process, it takes a large time, or it takes more time. Okay, so that's why it should be a moderate ignition temperature. And even once the burning takes place, it easily we should control that burning process easily. Okay, so these are the few properties we should consider while choosing or while considering the fuel as an ideal fuel. The main thing is high calorific value, or in other words, it should release a large amount of heat energy. It should not leave behind any undesirable substances and that can be harmful and affect the environment adversely. And they should possess a moderate ignition temperature and that the once catches fire easily controllable. Okay? So these are the some properties of ideal fuel. Then now we'll consider how we classify the fuels. Okay, so you know the fuels like kerosene oil and even LPG. These are all comes under, or even coke, coal, also fuels. Okay, that means there is a different categories. They are burning rate or they are available the source is different. Okay, on the basis of certain things, we classified the fuels into two categories. One is on the basis of their origins, how it origin. Okay, so based on that, we will classify the fuel into primary fuel and the secondary fuel. Same way, that is nothing but the classification on the basis of occurrence. That is natural fuel and artificial fuel. The man-made fuels is usually called it as an artificial fuel, and the fuel which is obtained from the nature called it as a natural fuels. Okay. So on the basis of their origin, fuels classified as primary and secondary fuels. And what do you mean by a primary fuel? So the fuel which is directly will found in the nature, that is called a primary fuels. The good example wood, crude oil, natural gas. So these are all comes under a primary fuel. If you derive the fuel from the primary fuel, okay, if you derive a fuel from the primary fuel, okay, a derived from the primary fuels, they are all comes under secondary fuel. That means from wood, if you get the other component transformed form, then that fuel would be called it as a secondary fuel. Okay? The fuel which is obtained from the nature considered as a primary fuel, and the fuel which is derived from the primary fuels are called secondary fuels. And here, even the man-made fuels, artificial fuels also comes under secondary fuels. Like tar, coal gas, coke, they all comes under secondary fuel because they are derived from the primary fuels. Petroleum components. From the crude oil, we'll get the petroleum products. And that crude oil is comes under primary fuel. From that, we'll get the secondary fuels. Okay, and again further they are classified based on their physical state. That primary fuels is classified based on their further classified based on their uh, state of existence. Okay, they are classified as a solid fuels, liquid fuels, and the other category of a fuel is what we called it as a gaseous fuel. Okay, solid fuel, the primary naturally occurring solid fuels like wood, coal, oil, etc. and from that we may get the artificial or the secondary fuels. Okay, and the one is the solid fuels, that means fuels which are found in their solid state at room temperature. Actually, at room temperature, on burning or on giving heat, it may turns to a liquid. So that's different. But at room temperature, it should be. It appears as a solid and are generally referred as a solid fuel. Okay? Solid fuels means the fuel which is in the solid state at room temperature and are generally referred as a solid fuel. They are the first kind of a fuel known to be used in the world. Okay, and from this solid fuel, we may get from the naturally occurring solid fuels, we may get a secondary fuels. Okay, here the solid fuels usually we use in the fires, industrial revolutions from the firing furnace to running steam engines, etc. And the advantage of solid fuel is easy transportation and storage. The main advantage of the solid fuel is easy transportation. And even it is easy to store the fuel, easy transportation, store the fuel, low production cost. As you observe, so most of the solid fuel, even in the case of artificial solid fuel, low production rate or the cost is very low. Then they ignite at moderate temperature. Ignite at moderate temperature. So that's why the solid fuel possesses this type of advantage. But the drawback what we observed in the solid fuel is here the large portion of the energy is wasted in the case of solid fuels because the ash or the unwanted components are produced. And the cost of handling is high and controlling once the burning takes place, the controlling also difficult. And ash content is high, burning with a cylinder or the cleaner clinker formation is also. Means some with the charcoal, thick charcoal like component, they will deposit it over the surface. Okay, so this is about the solid fuels. The solid fuel, it may be a naturally occurring fuels or a secondary fuels, and the fuels which is in the solid state at room temperature, and they all comes under solid fuels. And the first man invented fuel is a solid fuel, and even it is influenced by the things. Advantage is easier transportation, storing becomes easy, low production cost, low moderate ignition temperature. But ash content is very high. Most of the portion of energy is lost, and even it is controlling is difficult. Okay, so the example for primary fuel is wood, coal, oil, whereas a secondary fuel is charcoal, coal, etc. Then come to a next kind of fuel, what we call it as this is about solid fuel. The good example is wood, charcoal, okay, charcoal. They all comes under the solid fuel. Charcoal, then there's other things. That's a good example for solid fuel. For these are all primary solid fuel, and the secondary solid fuel example is coke, again charcoal, which is obtained from the wood, charcoal, and coal. These are the example for solid fuel. The next kind of fuel, that is liquid fuels. Again, the liquid fuels we may observe naturally or even the man-made. The naturally occurring one liquid fuel is crude oil. From this crude oil, we get different kinds of secondary fuel. Okay, generally the gasoline. Okay, and then diesel, then petrol, even synthetic petrol that is considered under secondary fuel petrol. Then even kerosene. Okay, so these all comes under secondary fuels. Okay, they all comes under secondary fuel. Petroleum is taken, or even it is a crude oil. Okay, that is a naturally occurring one. From that we'll get these things. Okay, now so this usually exists in a liquid form. Okay? The liquid fuels are derived from the fossilized remains of dead plants. That is, we already studied this. And animals by exposure to heat and pressure in the earth's crust. Okay? The fuels of the liquid fuels are flammable instead of liquid. Then what is the advantage of these liquid fuels? Usually, the liquid fuel on burning gives high energy. Okay? The higher calorific value per unit mass burn without ash. Okay? That is a loss is less loss of energy. Controlling the combustion becomes easy. Transportation easier through pipes and even stored indefinitely without loss requires less furnace space for combustion, loss of energy is comparatively low. Whereas in solid, that for combustion in the furnace, we need a large traverse. Whereas here, it is a less combustion, furnace is sufficient. The disadvantage is the cost of the liquid fuel is much higher compared to the solid fuels because it is crude oil or even it is refining process. It takes a much high cost. The storage of some liquid fuels becomes difficult and even it is costlier. Then greater risk of fire hazards because it catches fire at a moderate temperature, but once it catches the fire, the migration or the propagation rate is very high. And even sometimes special burning equipment is required for more efficient combustion. Okay? So these are the things comes under a liquid fuel. Sorry, it comes under a solid fuel. And the third and the most high calorific value of fuel, that is gaseous fuel. Okay? Here, the transportation through pipe becomes easy, like in the case of liquid fuels. Combustion is easy just by sparkling. You can these fuels are already known things, gaseous fuel, and they have a higher heat content, high calorific value. Cleaning after uses becomes easy. A very less ash content is observed. Okay? The disadvantage it requires the largest storage tank, and as they are highly inflammable, the chance for the hazardous is very high. Okay? So the fuel which is exist in a gaseous state are considered as a gaseous fuels. And mainly in gaseous fuels, what we observed the component is hydrogen and carbon are the main component on proper burning. On proper burning, we'll get carbon dioxide and water. The main natural or primary fuel is a natural gas. Natural gas is that is a fossil fuels, natural gas. And the secondary from this we can get coal gas and water gas. Like water gas is synthetic water gas and even producer gas. These are the few gases, even liquid petroleum gas. These are all derived gases and comes under secondary fuels. Naturally occurring gaseous fuel, that is natural gas, and other gaseous fuel, coal gas, producer gas, water gas, hydrogen, oil gas, they all comes under the secondary gaseous fuels. Okay, so these are the brief introductions of fuels. Okay, like three category they can be classified as a primary fuel and the secondary fuel. Again, it is like natural fuels and artificial or derived fuels. Again, it is further classified based on their existence: solid fuel, liquid fuel, and gaseous fuel. Okay, that is the how we measure the heat content that released during the combustion of a fuel. A solid, liquid, or a gaseous fuel that is usually expressed in terms of calorific value. Okay? So the calorific value is defined as the quantity of heat released when the unit quantity of fuel burnt completely in air or oxygen. Unit means mass by volume we consider when a quantity of heat released when unit quantity of fuel burnt completely in air or oxygen. As I already informed you in the beginning, say the burning process it requires oxygen and a little heat. On proper burning, it gives heat energy, plenty amount of heat energy, and this heat energy what we express what is taken as a calorific value. Okay. So calorific value. So here fuel is taken in terms of unit quantities in terms of mass by volume. Okay, a unit quantity, 1 unit is when you burn, the time how much quantity of heat is released that is calculated, and that is what we call it as considered as calorific value. Okay, the calorific value of a fuel sample is defined as the quantity of heat released. Okay, when unit quantity of uh, fuel burnt completely in air or oxygen. Okay, so that is usually taken in the unit calorie per gram, that is in the CGC unit. The SI system, that is a joules per kg. So for solid, if it is a liquid, it is taken as a cubic meter. Okay, mass is in terms of joules and joules per kg is taken for a solid fuel, and for a liquid is a per cubic meter in the case of liquid fuel. Yeah, calorie peak value. It is defined as the quantity of heat released when unit quantity of fuel burnt completely in air or oxygen. Again, you can define, you can take it in two ways. The quantity of heat released we can consider in two ways. The one is by considering the combustion product. Another one is just by omitting the combustion product. Based on that, we'll define a gross calorific value and high net calorific value. This gross calorific value is also called as a higher calorific value. There are two kinds. One is a higher calorific value, other one is a lower or net calorific value. The gross calorific value is defined as the quantity of heat released. Same way, the quantity of heat released when unit quantity of burn. Same way, when a quantity of heat released when unit quantity of fuel burnt completely in air or oxygen, and further, the combustion product are taken into consideration, are cooled to room temperature. Okay, are cooled to room temperature. Some amount of heat energy is absorbed by the combustion product. That is nothing but the carbon dioxide and water moisture. They may be absorbed some amount of heat energy, and that energy also taken into consideration under during combustion, and that is what we call it as higher calorific value or gross calorific value. That is, it is defined as the quantity of heat released when unit quantity of fuel is burnt completely in air and the combustion products are allowed to cool to room temperature. Whereas in the case of net calorific value, so here also we'll burn a we'll consider a heat released when unit quantity of burnt completely in air and the combustion products are allowed to escape to the atmosphere or are let off into the atmosphere. Okay, will not consider the quantity of heat absorbed during the by the combustion product. Okay, combustion product are allowed to cool to room temperature in the case of gross calorific value. In the case of net calorific value, combustion products are escaped to the atmosphere or products are let off into the atmosphere. Okay, so this is a calorific value. The gross calorific value, net calorific value. Then, so if you observe the difference between a gross calorific value and the net calorific value, or if you observe the quantity of heat released during, by considering the combustion product that absorb heat absorbed by the combustion product, it is always higher than the net calorific value. That's why it is called as a higher calorific value. Okay, the net calorific value is always less than the gross calorific value. Okay, or higher calorific value is always higher than the lower calorific value, because in the gross calorific value it is the total quantity of heat liberated. Total quantity of heat liberated, including latent heat of steam. Including latent heat of steam. Okay? That is nothing but the amount of energy absorbed by a water body. Okay? It is including latent heat of steam. In other words, lower calorific value and higher calorific value differ by an amount of latent heat of steam. It's just a difference what we observed between higher calorific value and the lower calorific value. It is the difference of latent heat of steam during complete combustion of unit quantity of fuel. Okay, so net calorific value, we'll write it as a gross, taken as a, how we calculate the net calorific value. We can easily calculate a gross calorific value, okay, by the experiment. So gross calorific value minus the latent heat of steam gives the net calorific value. Then how we observe the latent heat of steam, that depends upon the percentage of hydrogen present in the fuel. Okay, how much quantity of hydrogen present, that in turn shows the latent heat of steam. See, usually 2 gram, if you observe the water moisture contains, it contains a 2 gram of hydrogen and can able to produce a 12, so 18 gram of water. Okay, 2 gram of hydrogen on burning produces 18 gram of moisture. That means, therefore, 1 gram of hydrogen produces 9 gram of water. The latent heat of steam is 587. Along with this, the quantity of hydrogen present in the sample. If you want to express in terms of percentage, we'll take it this way. That is net calorific value minus gross calorific value in, okay, net calorific value equal to gross calorific value minus mass of hydrogen into 9 into latent heat of steam. The net calorific value minus equal to gross calorific value minus mass of hydrogen. So minus mass of hydrogen. Okay. So this is the hydrogen mass multiplied by 9. Okay. I'll take 9 because 1 gram of hydrogen produces 9 gram of water. 9 multiplied by latent heat of steam. Or if you want to express this one in terms of percentage, if the hydrogen is expressed in terms of percentage, we take GCV minus percentage of hydrogen, okay, percentage of hydrogen into, even that is in terms of percentage, that is 9 by 100, okay, that is 9 by 100 hydrogen, okay, that way into 587. This is the net calorific value of fuel sample. So the net calorific value equal to gross calorific value minus latent heat of steam. Okay. So the net calorific value is always less than the gross calorific value by an amount of latent heat of steam, and the latent heat of steam, that depends on percentage of hydrogen present in the fuel sample. So that's why NCV we can write it as GCV minus percentage of hydrogen into 587 into 9. Okay. This is a formula used to calculate net calorific value. Okay. Any doubt, students? Just recollect the gross calorific value we define this way. It is the quantity of heat released when unit quantity of fuel burnt completely in air or oxygen. That higher calorific value that is defined is the quantity of heat released when unit quantity of fuel is burnt completely in air and the combustion products are cooled to room temperature. The net calorific value is the quantity of heat released when unit quantity of fuel is burnt completely in air and the combustion products are let off into the atmosphere. The net calorific value is less than the gross calorific value. So the lower calorific value is less than the gross calorific value by an amount of latent heat of steam formed during the complete combustion of unit quantity of fuel. So that is LCV is equal to GCV minus percentage of hydrogen into 587 into 9.